Hello everyone, this is the Hioki IR 405720 insulation resistance tester. I bought it from the official distributor of Hioki in the Philippines last 2019. It was indispensable when it came to be needed when I was troubleshooting and repairing a problem in a residential wiring. It came in a sturdy retail box, unabridged specifications of the equipment at the back, English user's manual, and inspection certificate. It has a built-in carrying case with carrying strap. The strap is held in place by 4 O-rings. This is a hard plastic carrying case. The cover can be slipped under the instrument to make way for space on top of it. The instrument only occupies one half of the carrying case. The other half is reserved for organizing the test leads and test cable. The test leads are high quality and flexible. I have measured them to be 1.38 meters from the elbow to the tip of the test leads. Both of them have at least a category 3 rating of 600 volts. The unit also included an alligator clip. The unit came complete with 4 of these Toshiba disposable batteries, but I have already replaced them with these Fujitsu rechargeable batteries, which works just as well. On the rightmost portion of the battery compartment, we can find the fuse protection of the instrument. It's a fast-acting 500 mA 1000 volt rated fuse. The black cable goes to the earth terminal point, and the red cable goes to the line terminal point. The IR4057 has not just one DC voltage setting, but 5. This makes it more flexible. One or the other voltage may be best for a particular situation. It has a dedicated 200 mA continuity function. When switched to the voltage function, it is capable of measuring AC and DC voltages up to 600 volts. When measuring voltage, we put the test leads into the measurement points without having to use the measure key. This is the backlight button. The light will stay on for 3 minutes. To disable the auto turn off of the backlight, press and hold it for more than 2 seconds until you hear a double beep. This is the 0 ohm adjuster button or 0 ohm adjuster key. The flashing red LED is called the live circuit indicator. It lights up when voltage remains between input terminals. This is the comparator key. The comparator key sets the comparator's judgment reference value. This is the release key. We press this release key before making measurements to set the instrument to the 500 volts or 1000 volts DC range. This is to prevent inadvertent application of the test signal. How do we set the comparator value? Each of these DC test voltages can have its own comparator value. We can even leave it at off. Let's try the 125 volts DC. Let's make these 10 mega ohms, just for an example. So now at 125 volts DC test voltage, we have a comparator value of 10 mega ohms. Now every time we make a measurement, if the result of that measurement is greater than 10 mega ohms, the instrument will make a pass judgment. If the measured value is less than 10 megaohms, the screen will turn red and the instrument will make a fail judgment. Let's try the 1000 volts DC. Now the lock release button for the 500 volts and 1000 volts DC test voltage is blinking. We must be deliberate and sure when we need to make a 500 volt or 1000 volt DC measurement. So this lock release button provides an extra layer of safety. Notice that even if we press the measure key, the instrument will not make any measurement. But now that the lock release button has been pressed, we can make a measurement in either 500 volts or 1000 volts. Now to set the comparator value for 1000 volts DC. Let's make this 20 megaohms. Let me just quickly illustrate the comparator function. I'm going to press the measure key without the test leads connected to anything. The instrument makes a pass judgment. This is because it measures 250 megaohms, way above the 10 megaohm limit. Notice that the instrument makes a loud beep and the screen turns red. This alerts the operator that the result of the insulation resistance test is below the comparator value. I'm going to connect my black test lead to this metallic DIN rail where my circuit breakers are mounted. This will serve as ground. The terminal block will serve as my test points. I'll start at 125 volts DC. The comparator value, I have already set this at 10 megaohms. In order to make quick measurements in succession, I'm going to lift the lever of the measure key. As you can see, the instrument makes a fast measurement, and all of these readings are high. So my insulation resistance on this demonstration board is excellent. Next, I'll test with 1000 volts DC. The release key is blinking, so in order to proceed with the measurement, we must press this. And here I have already set the comparator value to 20 megaohms. The insulation resistance values are also high, and just like at 125 volts DC, the instrument makes a fast calculation, a fast measurement. So far the results have been satisfactory, but now I'm going to simulate a failed insulation resistance. I have connected a parallel line here with a degraded insulator. I'm just going to use 125 volts DC for this illustration. My threshold value here is 10 megaohms. The comparator function can help you make your case with your client by providing them with visual evidence of a failed or passed insulation resistance. Before I end this video, I'm going to measure the actual output of the DC test voltages of my Hioki IR4057 with the Hioki CM4376, my AC-DC clamp meter, which is capable of measuring up to 1700 volts DC. I'll start at 50 volts DC. That's 57.1 volts DC. 125 volts. That's 134.1 volts. 250 volts DC test voltage. That's 267.4 volts DC. 500 volts DC test voltage. That's 537.2 volts. And finally, 1000 volts DC test voltage. That's 1076 volts DC. I can't really think of anything negative to say about the Hioki 4057, but just to pick on something, I'd say that the strap can get in the way. It is not easily removed once you've attached it. The location of the test lead termination on top of the instrument was a little awkward at first. There's no tilt stand. The instrument had to be laid flat on the surface. The Hioki IR4057 was fully focused on its core function of insulation and continuity testing. You won't find capacitance, temperature, or diode functions, but when it comes to its main job, it delivers with ease of use, safety, and efficiency to produce correct results. The output DC test voltages were true, digital and analog display in a large backlit LCD, quick and valuable pass and fail judgment references, and last but not the least, one can say that it's hard to argue against the quality of an equipment that's made in Japan. Thanks for watching. Stay safe.